Okay, let's look at the next problem, student absences versus grades. And maybe you could try this on your own before seeing what I come up with. Okay, because if we did this in class, I would probably have you guys do this and then check it. Okay, we're looking at student absences versus grades. Um, First thing you want to do is try to get a line of best fit. They don't have it for you. You just want to try to get about the same number of points above the line as below the line. And you have a line tool. I have this kind of hard to use, probably not easy for you to use either. But I'm just going to put it right here. I have about the same number of points above as below. Maybe I should shift it over a little to get this below. Okay, about right there. So I would put it here. Use blue so you don't have different colors there. Okay, there's my line of best fit. Okay, yours could be different. Okay, we're going to first find the equation of the line of best fit again, and then we're going to make predictions on the next slide. We want to predict a grade. Let's see, I wrote it down. Predict a grade for 12 absences and 15 absences. Okay, so it looks like the more absences a student has, okay, as you go from left to right on your graph, it looks like the grades are falling. So maybe, at least in this particular situation with these students, that's what's happening. The more that they're absent, okay, the lower their grades are, okay, in general. Okay, so to find the equation, we need the y-intercept and the slope. Okay, the y-intercept of my line, okay, may not be the same as yours. Mine is like 100, almost exactly 100. Okay, find the slope. So find the slope using 2 corner points. And this is not always easy to do, but I'm going, and sometimes things are just close enough. Like I think this point right here is pretty close to being a corner. It's a little shy, but I want to just count it as close enough. And I want to do the same right here. Now, we could argue that those really aren't very good, but we're just trying to do the best we can to get an approximation. So if I'm doing rise over run to get from this point to this point, okay, my rise over run, I'm going down one space over one space. Okay, but down one space, look at your scale. Okay, this is 60, this is 80, this is 70. So it must be 65, 70, 75, 80. So kind of like the other one, you're going down 5. I'm assuming when they say grade, they're talking points. So we're going down 5 points in a grade, maybe 5 percentage points. Okay, we're going over one space. Okay, look at your x-axis. Notice here, one space on your x-axis is two absences. 2 absences. So we're going down 5 points for every 2 absences. So you could think of it as -5 over 2, or you could change that to a decimal and think of it as -2.5 if you want to. Okay, since I want to be using my calculator, I want to go ahead and think of this as -2.5 points in your grade per absence. Okay, so in general, these students are losing 2.5 points on their grade for each absence they have. Okay, so the slope is -2.5. Okay, so to come up with your equation, you put the slope, the -2.5, in front of your x. You put the y-intercept, the initial amount, at the end after the plus sign. And we have y equals -2.5x plus 100. Okay. On the next slide, it's going to ask to predict for 12 absences, what would be the student's grade? So you could look at 12, go straight up, and see where the line is at 12. Okay, it looks like if I'm right there on the blue line, looks to me it's about a 75. Okay, so you could predict it with the line itself, or you could take that value of 12 and put it in for x and use the equation. Let's do that. Let's see how close it is. So y equals negative 2.5 times 12 plus 100. Okay, so I'm getting negative 30 when I multiply, add 100, and I get a score of 70, a class grade of 70. What did we say it was? Okay, from the actual picture of the line, we said about 75. Okay, that's okay. These are just approximations. They're not going to be always the same. Okay, so for a grade of 50, for 50 absences, notice we really have no choice. We have no choice to use the picture of the line because it's off the graph. So we could just, our only choice is really to use the equation. I think you can kind of see what's going to happen here. If we put 50 in for x, we have negative 2.5 times 50. We get negative 125. Negative 25 plus 100 is negative 25. Okay, so you see that 50, you really don't get a real good answer, except to know that you're probably not going to do very well. Okay, maybe by the information we have, it's saying you'd have a 0%. Okay, of course you can't have less than 0%, but you still get a negative 25 there. Okay, so sometimes in your scatter plot, some points, some values don't really make as much sense as others. Okay, but we're just using them to approximate some answers to some questions. Okay, keep working on these. Let me know if you have questions. There'll be a Khan Academy over this, and we'll look at this again. But please keep me posted on how you're doing.